So this is our first, we'll call it a quick draw. So when you do a quick draw, you need to draw the figure, label at least 3 points on it, like literally label it. So it's got to be drawn and it's got to be labeled. Okay. We'll just do these, just kind of increase our speed and stuff like that. So here's the first one, y equals x squared. And again, nice graph, nice sketch, not perfect. I think that's it for the new parent functions that we learned. Just 4 of them. And we want to do this no calculator, no notes, just from our memory. It'll take a while to get there. Mason.
How many points do you want?
At least 3. Okay. Most of them just 3 will do it. Pencil down when you're done. That way I know kind of where we are. Okay, that was about 4 minutes. This is kind of like having a pop quiz and just, I didn't know we were doing this. Okay, so if you didn't get these right, that's fine. Let me show you how I would do this. So for a parabola, I would probably put the vertex here, and like we talked about, right 1 up 1 squared, right 2 up 2 squared, left 1 up 1 squared like this. And then I draw the graph from here to here like that, as good as I could. Please extend it to the ends. You don't have to put the arrows on there. That gives people a good idea that you know exactly what you're doing. I'd label the vertex for sure because that's a really important point. I'm going to label 2, 4, and I'm going to label 1 over here. And the reason I'm going to do that is because anybody looking at that would recognize, oh, there's some symmetry there, and you really understand really both the points on both sides of the vertex. Okay, the next one, square root graph, top half of a sideways parabola. So we're going to have 0, 0, 1, 1, and then 4, 2. If you really wanted to impress somebody, you'd put a point right there, but we're going to label 0, 0, 1, 1, and then 4, 2. Good there? Okay, next one. This is, as Dee described it, kind of like a sideways parabola, but it's got both halves. But it's definitely not a parabola because it goes through 0, 0, 1, 1. Okay, but then it goes through the next nice point is over here at 8, 2, and then it has the same exact shape over here. So if I were going to draw a decent sketch of that one, I'd make it look like this, and I'd probably label 0, 0. I'd probably label 1, 1, and then either 8, 2, or maybe I'd do one on the other side. That might be a little bit more convincing if I did the 1, 1, and then the -8, -2. Okay, so that right there, I consider that's very convincing to somebody who's looking at your paper that, oh, you know what you're doing. Can somebody raise their hand and tell us if we have an absolute value in a function, what's kind of the shape going to look like? It's going to have roughly what shape to it? Mason? It's going to have some sort of V shape to it. This one is a perfect 45 going up on the way out and a perfect 45 coming down on the way in. So 0, 0, 1, 1, and then -1, +1. You could convince somebody else you really know what you're doing by putting a point way over here. Not that you have to, but if you put one out there, it just makes it clear, hey, this is just going up on both sides. You know, whatever the y coordinate or whatever the x coordinate is, the y coordinate is exactly the same. It's just positive all the time. Okay? Now, there are 4 of them on here. Okay? So we're going to do fist to 4. Fist is, I didn't get any of these. I don't know what I'm doing yet. Okay, or 4, I think I got them all right. Okay, so just show me real quick. Okay, not too bad for having that sprung on you. Okay, so what I'm going to do is I'm going to pick up where we left off yesterday. We're going to pick up on the notes. You didn't have any homework yesterday. All I asked you to do is just spend some time thinking about those functions. And it looks like based on what happened there, looks like a lot of people actually did spend some time thinking about those functions. Okay, I'm thinking that this is going to go pretty quick. We've got a backside of the notes to do, a lot of which we're going to use our calculator for. So make sure you have your calculator out and ready to go. Yep. Hustle. But I want to take a look at this right now. We're going to talk domain and range on this. So I'm going to put a D and an R, and let's talk about roughly what this would look like. So this is a description of a situation where we're supposed to figure out what the domain and range is. And it says a parking lot has no charge for the first 59 minutes, but the minute we get to an hour, it starts charging us $2 per hour, or part of an hour with a maximum charge of $10 per day. So this is not a really long problem. It's also not very descriptive. How long are we going to park there? Are we parking at the airport and we're going to be there for 2 weeks because we're on vacation or something? Okay. Are we checking out after a couple hours? So if I were to draw a sketch of this, this would be what along the x-axis? How would we label the x-axis? And there's a reason for it. Keely, what do you think? Hours. I like that. Okay, so we're going to do hours. Okay, and let's assume that we're going to do just 24 hours. Let's just say we're going to go for a day. Okay, what are we going to label the vertical axis as? Instead of the y-axis, we're going to call this, put something on here that reminds us of the type of story problem we're doing. Sai, what do you think? Dollars. Okay, so this is how much it's going to cost. And then I'm going to switch colors so we can see what's going on. For the first hour, how much does it cost? Let me ask this way, because that wasn't a very good question. For the first 42 minutes, how much does it cost? 0. For the first 59 minutes, how much does it cost? Okay. And the minute we hit 1 hour, 60 minutes, then it costs $2, right? So how would we represent a function that's just 0 all the way until we get to an hour? Mason?
You could do a piecewise.
Kind of. We're going to have a flat line right here. And the minute we get to the end of that flat line, which is 1 hour, it's going to jump up to how much? $2. okay? It's going to stay $2 for how long? Until we get to hour 2. In which case, the minute we get to hour 2, it's going to jump up to $4. And it's going to go like this. How long is it going to do that? Until 5 hours, because what happens at 5 hours?
It stops charging.
Yeah, it maxes out for the day. So it's going to go like this until we end up, so that's 6, that's 8, until it gets to 10, and then it's going to go like this. So I should probably move the 24 hours along here. So see why we call them sketches? Okay, so for the way we've described this, if you were paying attention yesterday, what's the domain of this function? According to the way we've described this, what's the domain for this function? How far left can you go? How far right can you go? And we always start with the smallest and go to the biggest. Wilson, what do you think?
So it'd be 0, but it'd be closed.
Yep.
And then it'd be to infinity.
We could go to infinity, but let's just say the way we were talking about this, we added some information that we're just going to stay there for a day, so we're going to go to 24 hours. Is that okay? Everybody good with that? Okay, what about the range? This is a little weird, okay? And when Mason mentioned a piecewise function here, it kind of gets into this. This is a little strange. What if we squish this onto the y-axis? How far down do we go? How far up do we go? Think about it for a second. We're talking about money here. Do we get any negatives? Nope. Do we go all the way up to infinity? Nope. So where do we start getting answers and where do we stop getting answers, D?
0 to 10.
0 to 10. Okay, does anybody want to politely argue with that? Got a couple polite arguments here. Colson.
Well, it skips the odds, and so it couldn't be 0 to 10. It'd be 0, 2, 4, 6.
Okay,
8,
a
10.
better way to say this is to put this in set notation. Now, we're just starting out with this. I really wouldn't quibble about this. But yeah, they're either going to charge you 0 or 2 or 4 or 6 or 8 or 10. That's what they charge you. It's a set of how many numbers? 6 numbers. 6 charges, $0, $2, all the way up to $10. It doesn't cover things in between. This is an interval. That would mean it covers everything from 0 all the way up to 10, including $9.50, $1.73, and things like that. This is probably a better way to think of it, okay? Now, not a great question because it's not very specific. We had to add some details, but it does get the idea across, okay? Any questions? All right, we're going to flip the page over. We're going to do something that you've seen before, but I'm hoping that we kind of put this in a context where everybody can make sense of this and lock this away. Because for some reason, intercepts are something that people forget how to find quite often. So we want to know about intercepts. And remember, the x-intercepts is where it touches or crosses. So it can do either one of those things with the x-axis. And of course, the y-intercept is where it touches or crosses the y-axis. Now, when I teach students to do this, especially when they're doing higher math, because they've forgotten this stuff a few times, okay, technically this is how you do it. You substitute a 0, if you want to find the x-intercept, substitute a 0 in for y and then solve for x. If you want to find the y-intercept, you substitute a 0 in for x and you solve for the y. It seems a little counterintuitive. I can summarize all this together just in one thing, and it's this. Make a little xy table, plug in a 0 for x and you're going to find the y-intercept, plug in a 0 for y and you're going to find the x-intercept. All of this right here, all of those steps right there, you could sum up by saying just, hey, make a little xy table, plug in a 0 for x, you'll find the y-intercept, plug in a 0 for y, you'll find the x-intercept. And then don't forget, we usually write these as ordered pairs. So if we're doing this on a linear function, it's really pretty easy. So here's what I'm going to do. I'm going to make a little xy table. I'm going to plug in a 0 for x. I'm going to find the y-intercept. And I'm going to plug in a 0 for y, and I'm going to find the x-intercept. So this is written a little bit different. So anybody remember what f of x is? Brittany? It's the same as y. So this would be like having a y equals a 2 times 0 minus 1. by doing that, by plugging in a 0 for x, we're finding the y-intercept. So notice how easy this is. Y-intercepts are awesome. You plug in a number into a function, it spits out an answer. That's what you write right here. So this is the y-intercept. So I'm just going to write y-intercept right there. Got the answer. If I'm doing this, I'm plugging in a 0 for y. So I'm going to put a 0 right here and then 2x minus 1. X-intercepts are kind of a pain in the butt because you can only have one y-intercept. There are times where you get more than one x-intercept. We'll see a couple cases like that in just a second. The other thing is, when you're plugging in an x, if you know the x value, it's going to spit out the y value immediately like it did here. If you're solving for when y is going to equal 0, you usually end up solving an equation. So I'm going to move the 1 to the other side by adding 1. So this is 1 equals 2x. Divide both sides by 2, and I get x equals 1/2. So that is the x-intercept. So got the y-intercept right here, x-intercept right here. Both written as ordered pairs. Okay, and I take it like that, especially if they're labeled. So for the next one, I'm going to make a little xy table. Put in a 0 for x. That'll help me find the y-intercept. Put in a 0 for y. That'll help me find the x-intercept. So we're going to go ahead and plug it in. This one's a little unique because it's written in what we call kind of like a standardized form or a general form. 2 times 0 plus 5y equals 10. Oh, look, they did something really nice for us. This goes in evenly, and we get 2. So this is the y-intercept. Again, linear functions are pretty easy to work with. So we got 5 times 0 equals 10 there. So that's a 2x equals 10. So x would equal 5. Is everybody okay with the amount of work that I've shown? And please do not be shy, because if you've got a question, other people might have a question also. Easy enough? Okay, no one's got any questions. All right. Okay, grab your calculator. So it's going to take my calculator a little time to pull up. I've got an 84 on here. I've also got an 83. I just hit the button for the 84, and I'm going to hit the button for the 83. Yeah, it's an old crappy looking 83, but it comes up in like 3 seconds. Okay. Doesn't matter which one you graph with, whether it's this one or an 84 or a fancy one, they all do basically the same thing. So here's what we're looking for. Does anybody know what shape this is? Just look at it for a second. Don't say anything. Does anybody know what shape that is? It's a quadratic. It's going to make a parabola. Luckily, we don't have to worry about graphing this. We'll get to that point in a couple of units from now. But we're going to make our calculator graph this. So I'm going to go ahead and I'm going to hit second memory 712. Okay, so I've reset this. And then I'm just going to type this in. And when I work on the calculator, I try and make this a little bit smaller so we can see both of them at the same time. So it says find these, and this is what we have to do to find the x-intercept and what we have to do to find the y-intercept. So I'm going to show everybody this. So we're going to type in 3x squared, and then we're going to do minus 5x, and then minus 2. I always like hopping down on the next line. I say this to every class I teach. If you put the wrong thing in your calculator, very unsatisfying, students. Very unsatisfying. Put the wrong thing in the calculator, you're going to get the wrong answer. So it's worth an extra half a second to make sure that what's on your calculator screen matches what's on your paper. Do we have it in there right? We do. Okay, now most of the time, not all the time, would you go ahead and hit zoom and 6? Zoom 6 is the standard window. That gives us a decent picture. So we can kind of see, yep, it's a parabola. What do you know? Okay, so we're going to find the y-intercept because that's the easiest one to do. Hit the trace button, and this will happen almost every single time. Okay? It'll go to 0 for x, and then it has -2 in this particular case. So I'm going to write down 0, -2. And please make sure you label that. That is the y-intercept. We want to make sure that you're clear on what that is. That's the y-intercept. Okay, 0, -2. Some people will just say the y-intercept is -2. That's okay in kind of informal settings, but if you're going to tell people what it is, you want to include both of those. Okay, and let me know if you've done this before. We're going to find the x-intercepts, and for that, we're going to hit second calculate. Okay, and the one that we want here, Mason's smiling. Mason, do you want to tell us which one it is?
0.
It's the 0. It says that right on our paper. 0 means I want you to find where the function value is equal to 0. That's the fancy way we talk about x-intercepts once we get past like 8th or 9th grade. So we hit 0, and then here's what we've got to do. We've got to answer a few questions. We've got to give it a left bound, and those words are going to sound more and more familiar over the next couple of years. We got to give it a left bound. So we have to give it a little interval on which we want it to find the x-intercept, because we could have more than one. So if you want it to find the one over here on the left side, we're going to say, yep, that looks pretty good. I'm on the left side of that one. And then we'll come over here. We'll get on the right side of it. Looks pretty good. And you'll notice if you look closely, it put a little thing up here, put a little cursor. It's a little arrow. You'll be able to see this next one a little better. So what it's saying is, hey, I'm going to find the 0, the x-intercept between the two of these. If you want to take a guess, you can. Like we're pretty close right there. Hit enter, and there we go. So on this particular one, the x-intercept is negative. You okay if I do that? It's negative 0.3 repeated, right? -1/3, 0. Okay, and I'm going to write x ints next to that one. I'm never going to say x ints. I'm going to say those are the x-intercepts right here. And here comes the other one. I'm going to give you about a 1-minute head start to find the other one. You do the same thing again. You hit second calculate, okay, and you find the rest of them. There's one more. You go ahead and find it. Okay, you can see the little marks up there. I've got on the left and the right of where I think it is. I've got a guess that's in between there. I'm going to hit enter, and it's going to spit out 2, 0. Happens to be a nice one. So this is going to be 2, 0. Those are the 2 x-intercepts. Any questions? Okay, a couple more things. Don't forget to write them as ordered pairs. If you need to round, on this one I could write exactly what it was, 1/3. So please make sure you round appropriately. I want to show you one more thing. Everybody watch. I'm going to hit trace. That suddenly becomes a really ugly point. It used to look nice. Okay, if I want to go over here and I want to find the y-intercept, I can be anywhere on here. If I'm in trace mode and I just hit 0, it will put in 0 for x, and when you hit enter, it figures out what the y coordinate is. So there's our 0, -2. This can come in handy. Let's say I wanted to know what the function value was at 5. Type in a 5, hit enter, says it's 48. Way off the screen up at the top. Okay, any questions? All right, we're going to use the calculator again in just a second. We're going to come back here and introduce some new vocab. So what we're after on this is we're going to be talking about maxes and mins. So here's what a maximum is. It's just like you'd think. It occurs when the function reaches its largest y value. In other words, the graph comes to a peak, so the max would be right there. Or it occurs when it reaches it, or a minimum occurs when it reaches its smallest or least, if you want to say that, smallest y value. Or in other words, the graph comes to a trough, kind of a valley, low spot. All right, kind of makes sense. Yeah.
There's a typo. It says maximum twice.
Oh, it does. Thank you for catching that. Okay, this should say minimum. Thank you. I'm finding several typos. I should use spell check, and then I should read my own work. Right. Thanks for catching that. I owe you something. So here's how we do this. I think you're going to like this for a couple of reasons. One being it's the last two problems that we have to do here. So we're going to type these two functions in here. So we're going to type in negative x squared plus 4x and then plus 4. I'm going to hop down here. I'm going to make sure that it looks right. I'm going to hit graph. And I want to find the maximum. So we hit second trace for calculate. If you want the calculator to calculate anything on a graph, we use that top row of keys. We're going to hit second trace, which comes to calculate. So you can see value, you can see 0, and we want, based on the shape of that graph, what do we want? We want a maximum. So it's important to look at it first. Yep, I'm looking for a max. It's not going to find a min for us, okay, if we were not asking an appropriate question. So we're going to find the maximum. So this is going to be a, oops, wrong one. Yep, number 4. And all we have to do is say, hey, I want you to find it on this little interval. So this left bound and right bound thing, you can, if you want to, you can hit numbers rather than typing the arrow keys. And then if you want to guess, you can. Happens to say this one is, now, do you think that's really 2.00009? Okay. It's actually 2,8. Okay. The calculator kind of has tolerances that are built in. And what it does is it goes through some numeric algorithms and then it says, hey, you know what? I'm close enough. So if you see something like that, it's probably just 2, and we'll be able to kind of verify that algebraically a couple weeks from now. Okay, now, before you graph the next one, I want you to take a look at this. Take a good look. Anybody recognize that? What shape? Parabola. Opens which way? Does it point up or does it point down? Does it open up or open down? Opens up. What does the 2 and the 3 do? What does the 2 do? Left 2. What does the 3 do? Down 3. And we said it was a parabola that opens up, right? Max or min? Min. Where is it? -2, -3. Now, just for the heck of it, let's grab our calculator, make the calculator find it for us. So we're going to go back here. I'm going to clear that off. Parentheses, x plus 2, close parentheses and square it, and then -3. Hop down on the next row. Okay, go ahead and find the min on that. Got to make sure I get on the left
How to help
here.
kids, time to get to class.
And I'm going to type in a 0. And then if you want to guess, you can guess. If you don't want to guess, you don't have to. So again, there's that same type of thing. It says -2.0001. Again, that's just within the tolerances. It gets to a certain point and then it says, that's close enough. Here you go. Okay, any questions? All right. Okay, that is it for the notes. If you would circle how you're feeling about that right now, I would appreciate it. And then would you take a look at the assignment? Now,